so we're going to be starting Unit 1 today. This unit's going to be talking about limits. So you did see a little bit of this in pre-calculus, but everything you did in pre-calculus will be reviewed. So we're just going to kind of start from scratch here. So we're going to be talking about limits today. Today we're going to be looking at the graphical approach and from a table how you can find limits. So before we get started with this, we do have this picture here, this graph. If you remember, whenever a graph looks like this, that means you have the horizontal asymptotes, vertical asymptotes when you have a holes. And whenever f of x is set up as a polynomial divided by a polynomial, this is called a rational function. So you spent a lot of time in some of your previous math courses about rational functions. So what we're going to do is just figure out how they got all the aspects of this graph algebraically, just to give you a little reminder how to do that. So we're going to start, just write this back down. Okay, first thing I want to take a look at is I want to take a look at how do we get horizontal asymptotes from a rational function. So, to look at horizontal asymptotes, you look at the degree of the original function. So we're going to do this before we do any factoring, that way we don't mess anything up. So the degree means the highest exponent. So the highest exponent here is the squared, so I'm going to circle this term. And then in the denominator this says x squared, so the highest one is squared. So these are both a degree of 2, they're both squared. So they have the same degree. If they have the same degree, you're just going to use the coefficients out front. So for the horizontal asymptotes, 2 comes from the top over 1. So our horizontal asymptote is at y equals 2. Remember, it is y equals 2 because it is a line. So if you go and look at your graph over here, well, we do have a horizontal asymptote at y equals 2. So that's where that came from. Alright, other aspects of the graph are the vertical asymptotes and the holes. In order to get both of these, you have to be able to factor your rational function to see if anything's going to cancel. So, before we can do this, we need to factor. Alright, so just a little review on factoring. So I'm just going to factor the numerator first. Alright, so because there is not a GCF and there's a number out front, you have to use the AC method. So you're going to multiply 2 times -3, which will give us -6. We have to find two numbers that multiply to -6 and add to that 5. So we're going to use +6 and -1. You're going to bring down your first term, which is 2x squared. Instead of your middle term, 5x, you're going to put these two numbers. So we're going to have +6x and -1x. And then you're going to bring down your last term. So now you should have 4 terms. Since we have 4 terms now, we can use grouping. So if I group the first 2 terms, we're looking for the GCF there. So our GCF would be 2x. If I take 2x out of 2x squared, that leaves me with just an x. And if I take 2x out of 6x, that leaves me with just a 3. Alright, so then we're going to group this last 2 terms. Now the only thing they have in common is that negative, so we're going to take out a -1. If I take out -1 out of -1x, that'll leave me just with x. And then if I take out a -1 out of -3, that'll leave me with a +3. So to know if you factor correctly, whatever's in the parentheses should be the same. So x plus 3 is one of our factors. The other factor comes from the outside part. So the other factor is going to be 2x minus 1. And so that's how you factor that numerator there. Okay. So I'm going to rewrite my f of x. And my numerator is now factored into x plus 3 times 2x minus 1. Okay, the denominator factoring. So remember the denominator says up here x squared minus 9. So we can just use difference of squares. So the square root of x squared is just x, and the square root of 9 is 3. So you're going to have one factor that's x plus 3, and one factor that's x minus 3. So that's difference of squares. Okay, so what we're looking for is, does anything cancel? So if you notice, we have x plus 3 cancels here. Okay, whatever cancels is going to be where your whole is. So x plus 3, if we solve that, set it equal to 0 and solve, the x value of your whole should be negative 3. Now I want to be able to get the coordinate for this, so I need to be able to get the y value. So to get the y value for this, you're going to take the x value and you're going to plug it into what you didn't cancel. So where it says 2x minus 1, we're going to plug in 2 times negative 3 minus 1 over negative 3 minus 3. So we're going to have negative 7 over negative 6, which can just be positive 7 over 6. So our whole is at the ordered pair negative 3, 7, and 6. Alright, so let's check out our graph and make sure that's true. So if you look over here, we do have a whole. It is at negative 3, and 7, 6 is a little over 1, which is where that whole is. So when you factor, the whole is what you cross out, and to get the y value, you plug it into what was left. Alright, so next we need to get the vertical asymptote. So the vertical asymptote also comes from the factored part. So what you're looking at for the vertical asymptote is whatever's left over in the denominator. So we have x minus 3 left over, so we're going to set it equal to 0. So we have a vertical asymptote at x equals 3. Remember, a vertical asymptote is a line, so it needs to be written as x equals 3. So if you take a look at our graph here, well, we do have that vertical asymptote at x equals 3. Alright, so remember this was a rational function, and we were just figuring out how to get our asymptotes and our whole and where that came from algebraically. So what we're going to look at next, and I'm going to leave this graph up here, and I'm actually going to make it bigger. Okay, so looking at our graph, we need to figure out what these limits say. Okay. So you worked on limits last year a little bit. You definitely worked on end behavior and you wrote them in limit notation. So hopefully this will seem familiar to you, especially the first two. So for the first two here, it says as x approaches negative infinity, what is happening to the graph of f of x? Okay, well, when x is approaching negative infinity, that means x is getting really, really small. So those small x values would be over here. So this is just referring to the left end behavior. Okay, so left end behavior, which you actually looked at in Math 3. So according to this graph, as this graph is getting smaller and smaller x values, what is happening to the y values? Well, because there's that horizontal asymptote there, this line is getting closer and closer and closer to that asymptote, but it never touches. So the y value there is 2. Okay? When you are putting your answers, for any of the answers for the limits, you are putting y values. Okay, so keep that in mind. They're going to ask you about the x values, you're telling them about the y values. Okay, so when it says, and we'll go back and write it in limit notation in a minute, but it says as x approaches positive infinity, so when my x values are getting bigger and bigger and bigger, they're trying to figure out what's happening on the graph. So they're asking you about the right end behavior here. Okay, so as this graph, the x values are getting bigger and bigger, so the right side of this graph just getting closer and closer to that horizontal asymptote again, but it's never going to touch. So the y value that it's getting closer and closer to is going to be your 2 again. Okay, so how do we write this as calculus limit notation? It's the same format every time. So anytime you do limit, you're going to represent that by LIM. Underneath that, it's always going to say x approaches. Well, they're going to tell you what it approaches. Well, this time it approached negative infinity, so we're going to put that here. Okay, whatever graph you're talking about, normally it's f of x. This one has f of x, but whatever it's called, that's what's going to go beside of it. You're just going to get written a little bigger. Then it has an equal sign. And then you put the answer, what the y value was, and the answer was 2. So we have 2 there. Okay? So for the one underneath it, we're going to write LIM for limit. This one was as x approaches infinity. The graph we're looking at is f of x equals the y value we said it's approaching is 2. Just one thing I want you to make note on. This 2 came because we had horizontal asymptotes. That's where that 2 came from. Okay, so when they ask you about end behavior, if it reaches a number, it's reaching a horizontal asymptote. Alright, so next thing. This says, as x approaches -3 from the left. Alright, so let's take a minute here. -3 is on the graph here. -3 is where we had the hole, okay? But for limits, you are looking at what direction you're coming in. So if we come in, so this is the left side of the graph. If I run my cursor across and come in from the left side, and I get closer and closer and closer to that hole, the y value that I'm getting closer and closer to is that 7/6 that we figured out that goes with that hole. So as you're coming in from the left, you're getting closer and closer, you reach that y value of 7/6. Now, it is a hole, and it's not actually the point there, but that's perfectly fine. For limits, it's just what are you getting closer to, not what's actually there. Okay? So, let's go ahead and do this one underneath, and then we'll write them out. So then the next one says, as you're approaching -3 from the right. Well, same thing. If you come in the graph from the right, get closer and closer, you're still approaching that same hole that has that same y value of 7/6. Okay, so we're going to write these very similar. So we're writing a limit, because we are finding the limit. As x approaches, the number they told us was -3. If they tell you from the left or from the right, you have to write something to indicate that. So left is going to be represented by this little negative symbol at the top there. And then we always write what graph it is, equals, and we set our y value as 7/6. Okay, so to write the right one, we're going to do the limit as x approaches -3. So we were coming in from the right, so it's going to be indicated by a little plus. Then we always write our graph, f of x, and equals 7/6. Alright, so next, as x approaches +3 from the left. So let's find +3 on our graph. Well, we have a vertical asymptote here, okay? That's no big deal. So we're coming in from the left. So here's the graph coming in from the left. As we get closer and closer to the x value of 3, what is happening to the y values? They just keep going down, down, down. So they keep getting smaller and smaller and smaller. So those are approaching -infinity. Okay, so I'm going to go ahead and write that. The limit as x approaches 3 from the left, so you got to put the little minus, of f of x equals -infinity. And then same question, or same x value, but from the right side. So here, you come in from the right side and approach the x value of 3. Well, the y values keep getting bigger and bigger and bigger, so that's going to be approaching +infinity. So the limit as x approaches 3 from the right, so we're going to put the little plus, of f of x equals +infinity. Okay, so we're going to look at lots more examples with graphs, but this is just kind of an overview, and we will be writing them all with this calculus limit notation. This is how the limits will be written. This is just kind of in words, but this is how we'll be seeing it with this calculus notation.